Welcome to Module 1 of CM1502. In this unit, we will take a look at the building blocks of everything, which are atoms and molecules. Click Start button when you are ready to begin. These are what you should be capable to achieve at the end of the module. Once you finish, click Next to proceed. This is the menu. Click any tab to access the content of each topic, or click the Next button to proceed in order. Will take you back to when and how quantum physics started. The two buttons on the lower left are the exit and the menu button that you can click anytime you wish to take those actions. The next two videos are the revision about classical wave theory that you have learned before. Click play button to start the video.
Seats only. This was our time period, the frequency. In straight lines, surface, like wood or clothing. Pause the video and work them out.
This is how the realm of quantum physics is born. Planck proposed the idea that light is quantized as an ad hoc to solve the UV catastrophe and was awarded Nobel Prize for it. It was very impressive. Someone wrote a song about it.
Raleigh-Jean, you must be kidding. Wilhelm Wien is dead to me. When you write equations, they should work at every frequency. Measured wavelength radiating from an ideal black body at a given temperature. Show me your inconsistency and who the... In an act of desperation, he accepted an assumption. Didn't stop at it.
Everybody knows Albert Einstein of relativity and the Nobel Prize he won for it. He also... What? I didn't win the Nobel Prize for relativity. I won it for explaining the photoelectric effect. Right, of course, sorry. Einstein...
This animation by Open. Let's review how Einstein adopted Planck's idea of quantization of energy to explain the photoelectric effect. Click each tab to learn how Einstein concluded that light is made of a small wave packet, which he named it photon. Let's check your comprehension on how classical wave theory failed to explain the photoelectric effect. Click the Next button to proceed to the next. If you do not completely understand quantum physics, do not worry. Classical physics works perfectly fine in the real world. But since we are made of quantum objects, we just have to accept that we are one as well. It's just that it is not possible to see ourselves wobbling like a wave. Now let's check your comprehension on the duality of objects. Now let's look at the evolution of the current atomic model or quantum mechanical model. Click the dot on the timeline to reveal how the respective Nobel laureates shaped the quantum world. You can find a brief description of each quantum numbers in this slide. Note that the spin quantum number is not included here. These are the shapes of the atomic corresponding to each set of quantum. Let's check your comprehension of how these physicists shaped the quantum world. The shielding effect is the balance between the attraction between valence electrons and protons and the repulsion of valence and core electrons. In general, nuclear charge or number of protons can also be used to explain the trends across the table to a certain extent, between potassium and aluminum atom, which one is bigger and why it is so. We are now on the last topic of this module. Despite a minor error in the video, this is probably among the best animation and explanation available for free, regarding molecular orbitals theory.
Okay, shelves to form the new. Placing these numbers into my equation.
This is how the wave function of 1s atomic orbitals of a diatomic molecule are combined. The probability density is the highest. For the sake of simplicity, this is the showcase of how powerful molecular orbital theory is. While Lewis' structure fails to describe the two properties of oxygen molecules in a single structure, this video is also produced by Professor Davis. It is a short but very nice visualization to explain resonance.
Welcome to electrons. Shift to create resonance using double-headed arrows.
Let's check how well you understand the molecular orbital theory. Let's conclude Module 1 with the recap. Hover the mouse over each tab to reveal what you have learned so far. Hope all the objectives are met. See you in the next module.